Hello friends, today we'll be studying about scalars and vectors. You might very well be knowing that all physical quantities are divided into two categories, scalars and vectors. Scalars and vectors are like the ABCD of physics. Without them, you can't really understand the physical world. Hence, we need to understand how scalars behave and how vectors behave. What are scalars? What are vectors? Direction and magnitude of scalars and vectors. I should say actually magnitude of scalars and direction and magnitude of vectors. So one of the topic, the start topic is scalars, and the rest of the lesson is actually going to be only vectors. How to resolve vectors along the Cartesian coordinates in the rectangular coordinate system. What is a unit vector? Addition of vectors and subtraction as well. Addition and subtraction are carried out using the triangle and the parallelogram law of vectors. Multiplication of vectors. Multiplication involves scalar multiplication, that is multiplication of a vector by a scalar quantity, dot product and the properties of dot products, and cross product and the properties of cross products. And then we shall be looking at a few illustrative examples based upon vectors. So what is a scalar quantity? A scalar quantity is that physical quantity which for complete specification requires only magnitude to be specified. We don't really have to specify direction while specifying what a scalar quantity is. Examples of scalar quantities are time, energy, amount of work done, amount of substance, this is usually measured in moles, mass of a substance, power exerted, distance traveled, speed. All these quantities require only the magnitude and the units to be specified for us to know what we are talking about or what the person in front of us is trying to communicate. We don't really have to say that the energy used was 50 joules in each direction. We don't really have to specify the direction. Specifying the energy is enough. Like for instance, the mass of the pen that I'm holding is 100 grams. I don't need to specify 100 grams in what direction. Direction is not required for us to completely understand these quantities, and those are called as scalars. Vectors, however, require magnitude as well as direction for their complete specification. A few prominent examples are momentum. Momentum is represented as P and then an arrow on top of P. This arrow signifies that momentum happens to be a vector quantity. Momentum is actually given as mass times velocity of the object, and then you specify an arrow on top of the entire quantity mv. This can be considered to be mass into velocity vector, which is a scalar times a vector, and this gives us a vector quantity. Subsequently, we will see how scalar multiplication of vectors is carried out and how vector multiplication of vectors is carried out. Another example of a vector quantity would be displacement. Displacement is given as your final position minus your initial position. So when I say that a guy called Rahul is standing over here, and he moves forward 10 meters. So this 10 meter along with the arrow is the vector that represents the displacement of Rahul. Rahul's displacement vector. This vector is mathematically represented as d bar is equal to 10 meters into a small direction vector, let's say in the rightward direction, and this vector has magnitude of 1 unit. Let us say right now this vector is hat. E hat. That is how usually unit vectors are represented. This small thing over here, this is called as a unit vector. Another prominent examples of vector quantities are force, F bar, torque, tau bar, angular momentum, L bar. Okay, let us now understand what is the meaning of specifying magnitude only and specifying direction as well as magnitude in our next slide. Direction alone. What is the meaning of direction alone? We can't specify any quantity by giving direction alone. For instance, if we are living in India, this is our India, we are living in India, and somebody asks us, where is USA? What do we tell them? USA is towards the west or USA is towards the east? Okay, USA happens to be towards the west considering the way in which we usually view the world map. So this would be the correct answer. But we have really not specified how far USA is. For us to tell them how far USA is, not only will we have to point in the direction of USA, but we'll also have to tell them the exact magnitude in miles or kilometers of the distance between India and USA. So the position of USA with respect to India can be specified using something called as a position vector, which has a direction pointing from India to USA and which has a magnitude which is equal to the distance between India and USA. Let us say x miles. Let us look at another example. This is the house of a guy called Alex. One fine evening, Alex strolls outside the house and reaches a tree after traveling a path that is shown by the white arrow. This tree is exactly 100 meters towards the east from Alex's house. Here, I would like to point out that the distance traveled by Alex, which is actually given as the path length of this entire path, is different from the displacement, and it is certainly greater than the displacement. That is, distance has to be greater than equal to the displacement. Because while measuring distance, we measure the entire length of the path traversed. But while measuring displacement, we have to measure only the distance between the straight line distance between the final position of the object under consideration, which here happens to be Alex, and the initial position. This is Alex's final position denoted by XF. This is Alex's initial position XI. Let us look at time, for instance. Without going into metaphysics, we'll assume safely that time does not have a direction. We are not talking about the forward or the backward direction of time. This is very basic level physics, and we are just getting introduced to scalars and vectors. So time for us is a scalar quantity. It does not have direction. When I have to specify a time interval, then I'll just give you the magnitude of the amount of seconds, hours, or minutes that have passed between two events. Seconds, hours, and minutes are the units that we use to specify time. Let us say one event happened at 12 noon. That event was you waking up. And another event happened at 4 p.m. The event called you starting to study. I erase that and do it again. Let us say another event happened at 4 p.m. And let us say that another event happened at 4 p.m. The event called you starting to study. So the time interval between the two events is 4 hours. While I was trying to specify the time interval of 4 hours to you, I did not really have to tell you 4 hours in what direction? Towards the sun, towards Saturn, towards your girlfriend's house, towards anything. I do not have to specify that direction while I am telling you about the time interval between two events. That makes time a scalar quantity. Energy or work are more examples of scalar quantities. We don't really have to specify direction while specifying energy or work, the amount of energy expended or the amount of work done. Now we shall move on to something called as rectangular resolution of vectors. This is particularly important in the study of physics because numerous times subsequently while studying electric and magnetic fields, Newton's laws of motion, rotational motion, fluid dynamics, gravitation, SHM, you might need to resolve vectors along different directions. And here is how to do it. Let us first draw the Cartesian system of coordinates. Let us draw a vector which is represented as an arrow from the origin to the point R. And let us label the vector as R bar. I must tell you here first about the magnitude of a vector quantity being represented by this symbol. This represents the magnitude of a vector quantity. And sometimes we omit the two lines and just represent this as R without an arrow on the top. Now we are ready for the construction we need to make. We drop a perpendicular from R to the x-axis and label this point as M. And we drop a perpendicular from R to the y-axis and label this point as N. You might very well understand that given angle ROM is theta, RM is equal to R, which is nothing but the distance OR or the length OR into sine theta, and OM is equal to R into cos theta. So if this point R is represented as x comma y, x is nothing but the length OM and y is nothing but the length RM. So this is x and this is y. Here I must also tell you in short about what a unit vector is. A unit vector is simply like any other vector except its magnitude is 1 unit. Using unit vectors, we can represent any point in two-dimensional space as a vector having a component along the x-axis and a component along the y-axis. The unit vector along the x-axis is denoted by I cap, and the unit vector along the y-axis is denoted by j cap, or also sometimes called as j hat. So R essentially consists of two vectors, OM bar and ON bar. Vector OM bar can actually be represented as the magnitude of OM, which happens to be r cos theta that you can see just above, and then the direction of OM, which happens to be I cap. That is the use of unit vectors. They are heavily used to represent direction. Similarly, vector MR is given as r sin theta j cap. And so if I have to write the entire vector r, then I can write the entire vector r as r cos and hence if I have to write the entire vector r, I can write the entire vector r as r bar is equal to r cos theta I cap plus r sin theta j cap. And this particular representation of the vector r is called as a rectangular resolution of the vector. Here the x component of r is also denoted by rx, is r cos theta, and the y component of r is r sin theta. I'll give you another example of rectangular resolution which is very common. This is a wedge. This is a mass kept on the wedge. This mass is usually assumed to be a point mass. This is the angle theta. The force mg is acting downwards. By trigonometry, when you complete this triangle, you will understand that this angle is also theta, simply because the shown angle is 90 degree and the blue angle is 90 minus theta. So the green angle becomes 90 minus 90 minus theta, which is equal to theta. And as we have seen in the previous slide, that if a vector is to be resolved in rectangular axis or rectangular coordinates, then towards the angle theta comes the cos theta component of the vector, and away from the angle theta comes the sin theta component of the vector. We'll apply this principle over here and try to resolve the vector mg. But first, we ought to choose our axis appropriately. So this is one of my axis and this is another one of my axis. Let me label this axis as the y-axis and this as the x-axis. In physics, you might very often be required to choose the axis along the plane and perpendicular to the plane. It is not always possible to choose the axis according to your own convenience or according to the axis that is parallel to the ground and perpendicular to the ground. This is the ground in this case. To solve problems elegantly and efficiently, you have to maintain the freedom of choice of axis. So having said that, this is the force mg, and like we have established, this angle happens to be theta. So the force that acts along the y-axis is nothing but mg, and the force towards the angle theta, which is mg cos theta, and the force that acts along the x-axis is nothing but the force away from theta, the force component of mg away from theta, which is mg sin theta. Okay, I hope that is clear. We'll proceed to the next slide. Unit vector. We have already seen what a unit vector is. A unit vector is any vector whose magnitude or length is 1 unit. If this vector represents force, then this 1 implies 1 Newton or 1 dyne, according to what system you are using. If this 1 unit represents the displacement, then the magnitude can either represent kilometers, meters, centimeters, whatever it is, whatever you have chosen as 1 unit. Incidentally, let me also mention that vectors can be translated parallel to themselves. Or a vector, if you move the vector over here parallel to itself, then the vector does not change. You can move the vector anywhere in the plane, out of the plane, parallel to itself. The vector is not going to change. The vector is going to remain as it is. Let us look at how vectors are added and subtracted now. Subtraction of vectors is nothing but addition of vectors after reversing the second vector. We'll see how it is done. There are two methods to do addition and subtraction: the triangle law and the parallelogram law of vector addition and subtraction. Let us say we have two vectors, vector A and vector B. We are looking at the parallelogram law of vector addition first. The two vectors are drawn with their tails joining. The angle between them is theta. The construction that we have to do over here is we have to draw lines parallel to both the vectors from their heads. Heads meaning the arrows and tails meaning the dotted point that is opposite to the arrow. The resultant of these two vectors is given by the diagonal of the parallelogram. This resultant is R vector. R vector is written as A bar plus B bar. To find out the magnitude of R, we have to further construct a perpendicular on the line OB from the point R. Let the foot of the perpendicular be labeled M. Clearly, since RB is equal in magnitude to A, I can write the length of RB as A. Now, it is very apparent that the angle theta, which is essentially the angle AOB, is also the same as angle RBM because corresponding angles of parallel lines are congruent. Hence, in triangle RBM, we get RB cos theta is equal to BM. That is A cos theta is equal to BM, and OM is equal to OB plus BM. Now OB has the magnitude of the vector B, so this is equal to B plus BM, which has been found out to be A cos theta above. Similarly, in the same triangle RBM, RB sin theta is equal to RM. So this is equal to A sin theta. And hence, using Pythagoras theorem, in triangle ORM, we can write we can write OR square is equal to OM square plus RM square. That implies R square is equal to B plus A cos theta the whole square plus A sin theta the whole square. So this gives us B square plus a square cos square theta plus 2ab cos theta plus a square sin square theta, which is essentially implying that r is equal to under root of a square plus b square plus 2ab cos theta, after using the formula that sin square theta plus cos square theta equals 1. Now let us talk about subtraction of vectors. Let us say this is a vector A and this is a vector B. If we are going to subtract the vector B from the vector A, and if we are going to try to find out A bar minus B bar, what we'll have to do is first invert the vector B, that is multiply it by minus 1. So vector B inverted will look like minus B vector. And then we simply add this minus B vector with the vector A. The final diagram will look something like this. This is the vector B and this is the vector A. And then we proceed to use a regular method of completing the parallelogram and finding the resultant. Coming back to the slide of the resultant of vectors, we usually also try to specify the angle that the resultant vector makes with the vector B. This angle is alpha, and alpha is so specified. Wait, if we want to do A bar minus B bar, we have seen what we need to do. Now let us look at what the triangle law of addition of vectors is. The triangle law simply states that if I have a vector a1 over here and then a vector a2 drawn such that the base of vector a2 is at the head of vector a1, then the resultant of the two vectors shall be given as the third side of the triangle that is formed by a1 and a2 vectors. This is nothing different from the parallelogram law, except in the parallelogram law we would have drawn the vector a2 here. We have parallelly translated the vector a2 and drawn it over here as the opposite side of the parallelogram that we usually complete. There is a generalization of the triangle law of vector addition called as the polygon law. In the polygon law, we look at multiple vectors, which essentially are the vectors a1, a2, a3, a4 here, and the resultant of all the vectors is the vector joining the head of the first vector or the base of the first vector to the head of the last vector. The resultant is the vector joining the base of the first vector to the head of the last vector. Given the vectors are arranged in such a manner that a1 vector at its head has the tail of a2 vector, a2 vector at its head has the tail of a3 vector, and so on. What we essentially are doing is completing the triangles in this manner. This is R1, the resultant of A1 and A2. This is R2, the resultant of R1 and A3. And this is R, the resultant of R2 and A4. So all the vectors added together gives us the vector R. Let us look at an interesting theorem called as Lami's theorem. That is based on addition of vectors. What it says is, if three vectors that are concurrent add up to give a zero resultant, this angle being alpha, this angle being beta, and this angle being gamma. If these three vectors add up to give a zero resultant, then these vectors f1, f2, and f3 are related as f1 upon sine gamma is equal to f2 upon sine alpha is equal to f3 upon sine beta. Those who know a little trigonometry and can relate this to trigonometry of a triangle, they will figure out as a self exercise that this equation, which we call the Lami's theorem in physics, for concurrent forces under equilibrium or concurrent vectors under equilibrium, is nothing but the sine rule in trigonometry. The sine rule from the trigonometry of a triangle. Let us now look at multiplication of vectors. Multiplication of vectors can be carried out Let us now look at multiplication of vectors. Multiplication of vectors can be carried out using three different ways. The first one is called as scalar multiplication, that is multiplication of a vector by a scalar. Let us say this is our vector p bar. We multiply the vector p by the scalar 3 to give 3p bar. So scalar multiplication only expands or contracts the length of the vector, keeping the direction unchanged. So our vector 3p bar is simply 3 times as large as the vector p was, and it points in the same direction, p, p, p. If we multiply this vector with a scalar that is negative, then additionally we have to invert the sign of the original vector. This is the vector q bar. We multiply the vector q bar with -2. Then what we get is this vector -2q bar. So scalar multiplication by any real number essentially amounts to actually scaling the vector with that much amount, which is the magnitude of the real number that we are multiplying with the vector. If the real number is negative, additionally we also change the direction of the vector. Now comes one of the most important concepts in vectors that we shall be often using throughout the course of physics, and that is the concept of scalar or dot product of two vectors. So here we will be multiplying a vector quantity with another vector quantity, and the result shall be a scalar quantity. That is the reason this vector product of two vectors is called as a scalar product, because the result is a scalar quantity. Let us say we have got two vectors, a bar and the vector b bar. The scalar product gives us a value which is equal to a b cos theta, which is a scalar in itself. The dot notation is used to represent the scalar product. Dot means scalar product. What does the scalar product denote mathematically speaking? Mathematically speaking, it denotes the component of vector A onto B multiplied by the vector B itself. So let me illustrate it using a diagram. This is the vector A and this is the vector B. This is the angle theta between them. We drop a perpendicular from the head of A onto the vector B. So this component of A, as we have learned, is nothing but A cos theta, and this is the vector B. So we multiply the two together to get A cos theta times B is equal to AB cos theta. Similarly, we can also say that the scalar product is nothing but the component of B on the vector A times the vector A. So this will be actually B cos theta, again giving us B cos theta times A is equal to AB cos theta. This is particularly important because in physics we will subsequently encounter many quantities which shall have components along different physical quantities, and we will need to know what those components are. For instance, work is given as force times displacement. Displacement I am denoting as delta S for some particular reason. Power is given as force dot velocity. We have seen that these are scalar quantities, and the resultant of the dot product or the scalar product of two vectors is a scalar quantity. Incidentally, let us look at the Cartesian system or the rectangular system, in which we have got two axes, x, y, and here in this diagram we also choose to draw the third axis, namely the z axis. The unit vectors along x, y and z direction are I hat, j hat, with whom we are familiar, and here we introduce a new unit vector called as k hat, which is along the z axis. Let us try to find out the value of I hat dot I hat. According to the definition of dot product, this value comes out to be 1, which is the magnitude of I hat, into 1, which is the magnitude of I hat again, into cos of 0. That is the angle between I hat and I hat. I hat and I hat point in the same direction and hence have a 0 angle between them. So this equals 1. Similarly, it's easy to note that j hat dot j hat also equals 1, and k hat dot k hat also equals 1. But let us look at I hat dot j hat now. I hat dot j hat is equal to 1 into 1 into cos of 90 degree, and cos of 90 turns out to be 0. So I hat dot j hat is equal to 0. Similarly, j hat dot k hat and I hat dot k hat also are 0. There are a few properties of scalar products that we need to know, and the properties are as follows. If the angle theta between two given vectors is acute, then the dot product is positive. If the angle theta is obtuse, then the dot product is negative. It's easy to understand if you know the fact that cos theta is positive between 0 and 90 degree and negative for theta greater than 90 degree. That is theta between 90 degree and 180 degree. This is the graph of theta versus cos theta that I have drawn over here. This is the first property. The second property that we need to know is that the dot product is commutative. What that means is A dot B is equal to B dot A. The scalar product is commutative. The third thing that you need to note is that the dot product is distributive over addition. Mathematically, this means A dot B plus C is equal to A dot B plus A dot C. The next property is called as the associativity of the dot product. meaning the dot product is associative over multiplication. So A plus B dot C plus D is just like the regular algebraic bracket opening, which is equal to A bar dot C bar plus B bar dot C bar plus A bar dot D bar plus B bar dot D bar. If you take the dot product of A with itself, then you get the square of the magnitude of A, because this is equal to A cos 0, that is equal to A square. And last but not the least about dot product, if two vectors are represented as A bar is equal to AX I hat plus AY J hat plus AZ K hat, and B vector is equal to Bx I hat plus By J hat plus Bz K hat, then A vector dot B vector is given as Ax Bx plus Ay By plus Az Bz. The reason for that is simply the fact that I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1, and I dot j is equal to 0. All the cross terms turn out to be 0, and all the terms that involve unit vectors dotting with themselves come out to be 1. I must tell you a very important thing about vectors at this stage, and it is this: vectors have to follow this particular relation. A bar plus B bar has to be equal to B bar plus A bar. That is, vector addition has to be commutative. This is how we define vector addition to be. And please remember at this point that if two quantities do not follow this, then they cannot be considered to be vector quantities. Later in the chapter called rotational motion, we will come across one such example, which is angular displacement. The crown of being a vector is taken away from finite angular displacement exactly because it does not follow this particular identity, that A bar plus B bar has to be equal to B bar plus A bar. If two quantities are to be called as vectors, then they necessarily have to follow this. It's a deal breaker. If somebody is not following this, then sorry boss, you're no longer a vector. Next, we will learn about the cross product or the vector product of two vectors. This cross product is also called as the vector product. Let me see whether I can write like what has been typed. Of course I can. See, there is no difference. Okay, coming back to the cross product. Now we are going to multiply two vectors in such a way that the resultant that we get is going to be a vector as well. We define such multiplicative operations on vectors because these operations are highly required in our study of physics. These are two vectors, again A bar and B bar. We stick with the names A bar and B bar. And the cross product of two vectors is a vector that is perpendicular to the plane of A bar and B bar. This is the plane in which A bar and B bar are lying, and the cross product happens to be perpendicular to the plane. This is A bar cross B bar. Cross product is represented like this: A bar cross B bar. And this is n hat, a unit vector in the direction of A cross B, n hat. So from this diagram, what we can write is A cross B is equal to A B sine theta n hat. This is how the cross product is defined to be. Few very prominent examples are torque is equal to R cross F. R is the position vector, F is the force. The position vector represents in three-dimensional space the position of any given point. This is the position vector that represents the position of the point P right now. This is the three-dimensional space, X, Y, Z axis. So if there is a force over here, then you actually, while taking the cross product, draw it perpendicular to the plane containing P and F. The very popular rule for easily obtaining the direction of the cross product of any two vectors is called as the right hand thumb rule. What it states is, rotate the fingers of your right hand from vector A to vector B to curl the fingers into a fist like scenario, keeping the thumb outside and keeping it pointed perpendicular to the index finger. The direction of the thumb will tell you the direction of A cross B. So what this means is, since this is vector A and this is vector B, these are your fingers, this is your thumb. You curl the fingers from vector A towards vector B, and while doing so, the direction of your thumb, your awesome long Frankenstein thumb, the direction of your thumb will tell you the direction of A cross B. This is what it means. This is vector B. This is the meaning of the right hand rule. There are other methods, however, to find out the exact direction of the vector product. But this method is very well known, and it is important to realize that qualitatively a physicist should be able to find out the direction of the cross product of any two given vectors, no matter how they are oriented. That amount of imagination is required to be able to study physics successfully. Let us look at few other methods to compute the vector product before going on to problems. Okay, so if vector A is represented as 2i hat plus 3j hat plus 4k hat, and vector B is represented as I hat plus 5j hat plus 0k hat, nothing, no component in the z direction vector B has. So the first method to compute A cross B is the determinant method. So what you do over here is draw the following determinant: I, j, k, 2, 3, 4 and 1, 5, 0. So this gives us I hat. Solving this determinant gives us I hat 3 into 0 minus 4 into 5. So that's 0 minus 20 minus j hat and 2 into 0 minus 4 into 1, that's minus 4, plus k hat and 2 into 5 minus 3 into 1, so that is 7. So this is equal to minus 20 I hat plus 4 j hat plus 7 k hat. So this is the cross product A cross B. Let us look at another method. Here we have a shortcut technique. Just draw this circle and write ijk. If you go clockwise along this circle, then you will get the positive vector products, meaning I cross j. Using your right hand thumb rule also, you will be able to find out that this is equal to k. J cross k is equal to I, and k cross I happens to be equal to j. Similarly, I cross k is equal to minus j. If you go counterclockwise, then you'll have to add or insert a negative sign. K cross j is equal to minus I, and I cross k is equal to minus j. So using this and using regular bracket opening, we get A cross B is equal to 2i plus 3j plus 4k cross I plus 5j. So the first multiplication is I cross I. Okay, let me also write that I cross I is equal to I sine 0. Guys, recall that the angle between I and I is 0. So this comes out to be 0. Similarly, j cross j also is 0, and k cross k also is 0. So here I cross I is going to give you a result 0. J cross I has been written over here. Okay, I wrote this twice. J cross I comes here. J cross I gives you minus k, since you are going counterclockwise on this circle. Counterclockwise gives you negative signs and clockwise gives you positive signs. So j cross I, for j cross I you have to go counterclockwise, and hence you get minus k. So that is 3 into 1. So that will give you 3 into minus k. Finally, k cross I. K cross I shall give you j, as we have written out over here. So k cross I gives you j. So that's plus 4j. Now multiplying with the second term, 2 into 5 I cross j. So this is plus 10 I cross j is simply k. J cross j is going to be 0, and k cross j you will note here is equal to minus I. So 4 into 5 k cross j is equal to plus 20 minus I hat. So here what we get is minus 20 I hat plus 4 j hat plus 7 k hat, which is exactly what we got using method 1. So these are the two methods to find the cross product of any two given vectors represented in Cartesian coordinates. So this was an example. Now guys, let us move on to solving some problems based upon vectors. These problems will give us a lot of familiarity about how vector questions are to be approached and solved. Okay, before that, Okay, let us look at the first problem of vectors now. There is a hall that has the dimensions of 10, 12 and 14. So let me draw it here for you. This is the hall with the dimensions of 14, 12 and 10. Let me label the hall as well. A, B, C, D, E, F, G and H. A fly flies from D to F in the hall. So kindly look at triangle DFG for a moment. You will find that triangle DFG is a right angle triangle. Let me draw it here for you. Triangle DFG is a right angle triangle. Hence, DF square is equal to DG square plus GF square. This is the very well known famous Pythagoras theorem. But DG square itself happens to be a part of another right angle triangle, namely DGC. So DG square is also equal to DC square plus CG square plus GF square. So simply speaking, DF square is equal to 14 square plus 12 square plus 10 square. So that gives me 196 plus 144 plus 100, which amounts to a total of 440. DF square is equal to 440. Therefore, DF is equal to under root 440, and as we all know, under root 441 is 21. So the answer is terribly close to 21 and very far away from any of the other options given. So we shall mark 21 as the correct answer. Let us move on to the next question. So a vector is given. The vector is 2i hat plus 3j hat. So this is a vector that is in the xy plane, 2i hat plus 3j hat, and we have been asked the angle between the vector and the y-axis. So what we do is use the rectangular resolution of vectors that we have learnt, and we resolve the vectors along two directions. So our vector OR has two components, OM and ON. OM is 2 and ON is 3, and the angle that the vector makes with the y-axis has been asked. So tan of theta is nothing but NR divided by ON, and NR happens to be 2, so this is 2, and ON happens to be 3, so tan of theta is 2 by 3. So therefore theta is equal to tan inverse 2 by 3, which gives us answer B as the correct answer. Find the resultant of the three vectors OA, OB and OC as shown. So this is the vector OA. They have shown us the vector OA. This is OA, this is OB, and this is OC. Very common question, very typical. OA, OB, OC all have same magnitudes. So what we'll do over here is resolve the vector OB along two perpendicular directions. This angle is 45. So vector, this is A, B and C, and this is the arc of the circle that has been given. There are two ways to do this problem to resolve the vector OB along OA and along OC. Another way is to resolve OA along OB and OC along OB and perpendicular to OB. We'll opt for the second method because in doing that we simplify things for ourselves. So this vector OA can be resolved along OB and perpendicular to OB. Similarly, vector OC can be resolved along OB and perpendicular to OB. Since OA and OC are equal in magnitude and equally inclined to the vector OB, logically the components that are perpendicular to OB are going to get cancelled, and only the component of OA and OC that are along OB are going to get added. So the component of OA along OB is nothing but OA cos 45. This we have seen in a rectangular resolution. So that comes out to be R cos 45. And the component of OC along OB is nothing but OC sin 45. That comes out to be R sin 45. So this is equal to R upon root 2. This is also equal to R upon root 2. Adding these to OB, which is itself equal to R, adding these three together, we get R 1 plus 1 by root 2 plus 1 by root 2. That is equal to R 1 plus 2 by root 2, which is R into 1 plus root 2. 2 by root 2 comes out to be root 2. So this is the correct answer. B is the correct answer. Let us move on to the next question. Please read the question carefully. They have asked us the sum of vectors AB, AC, AD, AE and AF. The vectors are AB, AC, AD, AE and AF. From the symmetry of the situation, each of these angles is 30 degree. And all are equi-inclined to AD. So the components perpendicular to AD are going to disappear. Only the components parallel to AD are going to be sustained. And hence we get the sum to be equal to AD plus 2 times AC cos of 30 plus 2 times AB cos of 60. Now the answer is supposed to be expressed in terms of AO. If you look at the options, the question expects us to answer it in terms of AO. So we have to write the answer, the final answer, in terms of the length AO, because the direction is clearly going to be in the direction of AO. This we have also established from our logical deductions and the diagram and the symmetric diagram that we have in front of us. So let us write down everything in terms of AO. For that, we have to note that in triangle ABC, AB is nothing but AO in magnitude, and I'm going to write this as L and this as L. So AB and BC, both the lengths are equal to L. So what is the length AC? Since this angle is 30 degree, we get AM upon AB is equal to cos 30 is equal to root 3 by 2. Therefore, AM is equal to AB into root 3 by 2, which is L root 3 by 2. AC is equal to 2 times AM is equal to root 3 times L. So AC is equal to root 3 times L. So here, while substituting, AD we can directly write as 2AO, which is 2L. This is 2 into root 3 times L into cos of 30, which is root 3 by 2. So which gives us 3L. So this is 2AO plus 3L, which is nothing but 3AO, and the final term is AB cos 60. AB cos 60 is AB upon 2. So this gives us only AB in magnitude, whereas the direction is that of AO. So this will just give us AO, a single AO. So this is plus AO bar. So the answer comes out to be 6 AO bar. Let's move on to the next question now. Yeah, this seems to be an interesting one. At what angle must two forces x plus y is the magnitude of the first force and x minus y is the magnitude of the second force act so that the resultant may be under root of x square plus y square? It's easy to solve this question because we know the formula for resultant, right? R is equal to under root of a square plus b square plus 2ab cos theta. They have asked us theta. The resultant is under root of x square plus y square. So squaring this equation, we get r square is equal to x square plus y square from the given data in the question, which is over here, is equal to square of the right hand side, which is a square. Let the vector a be x plus y in magnitude, plus x minus y square plus 2 x plus y x minus y cos of theta. So this is x square plus y square plus 2xy plus x square plus y square minus 2xy plus 2x square minus y square cos theta. Just simplifying algebraically, x square plus y square goes 2xy goes away again. What we get is cos of theta is equal to minus of x square plus y square upon 2 into x square minus y square. So theta is simply cos inverse of minus of x square plus y square upon 2 into x square minus y square. This is the answer, which corresponds to option A. Moving on to the next question. Please read the question carefully. Very typical question. Two forces each of equal magnitude have a resultant of the same magnitude. The angle between the two forces is. This question can be solved using two methods. During the study of physics, students will often note that physics is very simple to study if you can imagine the diagram of the situation. Imagination of the diagram simplifies the situation to a very large extent. For instance, here, if you can imagine how the two forces will be inclined, particularly if you can imagine this, then you can understand that this is the only way in which the resultant can have a magnitude equal to both the forces. And these angles are 60 degree and 60 degree. So the inclination of the two forces is 120 degree. So this is called as the intuition based way of solving the problem. Intuition. Another very important concept. If you have physical intuition, only then can you imagine the diagram and imagine what is going to happen in the situation. Without that, it is very difficult for you to imagine and answer the physical question or physics problem correctly. You can also solve this problem mathematically. This is method 1, let's say. This is method 2. You can also solve this question mathematically as follows. So method 2 is the resultant r is given as, again we use the formula we have previously used, a square plus b square plus 2ab cos of theta. Therefore here r, a and b are all same in magnitude, so r is equal to under root r square plus 2 r cos theta. Therefore squaring we get r square is equal to r square plus 2r square cos theta. We simply cut r square from the entire equation to get 1 is equal to 1 plus 2 cos theta, which again gives us mathematically minus half is equal to cos theta. Therefore theta is equal to 120 degree. From here to here is plain trigonometric, there is no physics involved. So this is another very typical question. We get the answer as 120 degree. Moving on, the vector c bar is given as a bar plus b bar. Then c bar is always greater than a bar. Here it should be than, not then. C bar is always greater than a bar plus b bar. That is not necessary. A bar can be like this, b bar can be like this. Then the effective length of c bar is only this much. So option A is wrong. C bar is always equal to a plus b. Okay, option C I am looking at. C is always equal to a plus b, not necessarily true, because this is true only when they are in the same direction. C is never equal to a plus b, again not necessarily true. If a and b are in the same direction like this, then C is equal to a plus b, definitely. So the answer is this option B. It is possible to have mod of C bar less than mod of E bar and mod of C bar less than mod of B bar. Here, this is the example of that situation. Mod of C bar is less than mod of A bar and mod of B bar. It is certainly possible to have that. In such kind of questions, again you need imagination, and if you can imagine the vector C appropriately, then there should be no problem in solving this question or understanding the solution. Moving on to the next question, vectors f1, f2, f3, f4 have been given. Please read the question carefully. Following forces start acting on a particle at rest at the origin of the coordinate system simultaneously. Then the particle will move in xy plane, in yz plane, in xz plane, or along the x-axis. Where will the particle move exactly? So to answer this question, we have to find essentially the resultant of all the four forces, and which is very simple because the resultant is simply the addition of the x components of all four forces, namely these components. That is the x component of the final resultant. Then to find out the y component, we have to add the y components of individual forces. To find out the z component, we have to add the z component of individual forces. Okay, so the x component of the resultant fx, or let me stick to the colors that we started working with. Okay, so fx is equal to minus 4 plus 5 minus 3 plus 2. Fy is equal to minus 5 plus 8 plus 4 minus 3 plus 4 minus 3, and fz or fg is equal to 5 plus 6 minus 7 minus 2. So the answer of fx comes out to be minus 4 plus 5, that's 1, and minus 3 plus 2, that is 0. The answer of Fy comes out to be -5, -3 and 8 give you 0. So this comes out to be +4. And the answer of Fz comes out to be 5 plus 6, which gives you 11, and 7 and 2 gives you 9. So the answer is +2. So Fy and Fz are non-zero, whereas Fx is 0. So the particle is naturally going to move in the YZ plane. So this is the correct answer, B. What is the angle between P and the resultant of P plus Q and P minus Q? The resultant of P plus Q and P minus Q is equal to 2P bar, and the angle between P bar and 2P bar is simply 0. This is a very easy question. The next question is, the resultant of P bar and Q bar is perpendicular to P. What is the angle between P and Q? So let us say, and this is a vector Q and this is a vector P. Their resultant is perpendicular to P. So this is the situation. The situation is something like this. I should better draw it. Okay. So this is the vector P. This is the resultant R. So the angle naturally is obtuse. But this part of the angle, let us label theta, because this is 90 and we already know it. So essentially what is happening, the component of Q that is in the direction of P is cancelling P out, meaning Q sin theta is equal to P. Only then can the resultant be perpendicular to P. Therefore theta is equal to sin inverse of P upon Q. So that is the answer, C. Moving on to the next question. Please read the question carefully. The next question is, the resultant of A bar plus B bar is R1 bar. On reversing the vector B bar, the resultant becomes R2 bar. What is the value of R1 square plus R2 square? So this is what they mean. Initially this was the vector A bar and this was the vector B bar. The angle between them was theta. So R1 square is, as we know, A square plus B square plus 2AB cos of theta. If you reverse B now, the angle becomes 180 minus theta. It is not difficult to fathom that the new angle is 180 minus theta. So R2 square is equal to A square plus B square plus 2AB cos of 180 minus theta, and cos of 180 minus theta is nothing but minus cos theta, because the graph of cos is like this. This is 90, 180. So here clearly you can see that cos of 180 minus theta is minus cos theta. So R2 square is equal to A square plus B square minus 2AB cos theta. Okay, if you add R1, if you add equations 1 and 2, you get R1 square plus R2 square. That is what has been asked. This is simply 2 times A square plus B square, because this plus 2AB cos theta and this minus 2AB cos theta is going to get cancelled after addition. Next, the resultant of two vectors P bar and Q bar is R bar. If Q is doubled, the new resultant is perpendicular to P, then R equals. Okay, we have seen a sum that is very similar to this sum actually. So the resultant of P and Q is the vector R. This is the vector P, this is the vector, let's say, Q. The resultant is the vector r. Alright. If q is doubled, then the new resultant is perpendicular to p. Okay. If q is doubled, then the new resultant becomes perpendicular to p. So our diagram has to be drawn better actually. So the resultant of p and q is the vector r, and if q is doubled, then this vector r becomes perpendicular to the vector p. Okay, so after q is doubled, the angle between the vector q and the resultant, let it be theta, and let this angle be 90. This angle is 90. Okay, so 2q into sine of theta again is equal to p, like we have discussed in one earlier problem. This is possible only if 2q sine theta is equal to p, that is the leftward horizontal component of 2q. This is the vector 2q. The leftward horizontal component of the vector 2q is cancelling out the vector p. Only then can the resultant be perpendicular to the vector p. So 2q sine theta is equal to p. Alright, so now as we know, the vector p and q have the angle theta between them. So theta is given as sine inverse of p upon 2q, or if we draw a triangle, then theta will be p 2q, and then this will be 4q square minus p square will be the third side. So what does the vector r equal? So the vector r equals under root p square plus q square plus 2pq cos theta. So this is equal to under root p square plus q square plus 2pq, and cos theta is nothing but under root 4q square minus p square upon 2q. Cancelling q and 2, what we get is this is equal to under root p square plus q square plus under root 4q square minus p square. Let's check out the next question. Two forces F1 and F2 are acting on a body. One force is doubled that of the other force, and the resultant is equal to the greater force. The angle between the two forces is. So resultant is equal to the greater force. So this is the resultant. This is the greater of the two forces. Let us say F2, and one force is double that of the other force. So F2 is equal to 2 times F1. Okay. So using the formula, R is equal to under root F1 square plus F2 square plus 2 F1 F2 cos of theta, and substituting F2 as 2 times F1, we get R is equal to F2 is equal to 2 times F1 as given in the question is equal to under root f1 square plus 4f1 square plus 2 f1 into 2 f1 into cos of theta. So squaring we get 4 f1 square is equal to 5 f1 square plus 4 f1 square cos of theta, which gives us on cancellation minus 1 by 4 is equal to cos theta. Therefore theta is equal to cos inverse of minus 1 by 4. Cos inverse minus 1 by 4. That's the answer. Here we have got a circle and a particle is moving along the circle. Velocity along two instances is given. This velocity is the final velocity Vf. This velocity is the initial velocity Vi. If I draw the diagram over here, it looks something like this. This is the angle theta. This is Vf and this is Vi. The magnitude of the velocity is the same. These angles are 90 degree. Extending this line back and considering quadrilateral ABCD, what we get is this angle is 180 minus theta, and hence this angle is theta. So the angle between Vf and Vi is theta. So the angle between Vf and minus of Vi, that is what we require. Minus of Vi is what we require to find Vf minus Vi vectors magnitude. Vf minus Vi vectors magnitude. So this angle is 180 minus theta. So the resultant shall be given as under root of Vf square plus Vi square plus 2Vf Vi cos of 180 minus theta. So R is equal to under root V square plus 2V square cos of minus theta. So this equals V under root 1 minus cos theta whole into 2. Some simplification is required. After some simplification you will get this formula. So this is equal to V under root 2 into under root 2 sine squared theta by 2. Continuing to the left hand side, we get this equal to V under root 2 into under root 2 into under root sine squared theta by 2. So that is equal to 2V sine of theta by 2. It is advisable from the perspective of learning circular motion well to actually memorize this result. So 2V sine of theta by 2 comes out to be 2V sine of 40 by 2. So 2V sine 20. So this is the answer. C. Please read the next question carefully. There is a particle that is traveling towards east with a velocity of 5 meters per second. It turns north. Velocity is constant 5 meters per second in magnitude. The direction turns north. The average acceleration average is defined as change in velocity upon change in time. So what is the change in velocity? Vf minus of vi. So that comes out to be 5 root 2. That is the magnitude of change in velocity. So the magnitude of change in velocity is 5 root 2. Magnitude of acceleration has been asked. The direction is clearly apparent from the diagram. It is north west direction. Actually, we can see that only one of the options shows northwest. Yet still we'll solve the entire question. So this is 5 root 2 divided by delta t is 10 seconds. So this is root 2 by 2 or 1 by root 2. B is the correct answer. And now let us move on to the next question. Please read the question carefully. Vector A and vector B are at right angles to each other. So their cross product A cross B is equal to AB sine 90 n hat. Sine 90 happens to be 1, so this is not going to be 0. A minus B cannot be 0 and A plus B also cannot be 0. So these are correct options. Correct meaning these options should not be ticked. A cross B is not equal to 0 and A dot B, let us check at A dot B. A dot B is equal to A B cos of 90 degree. So this is equal to AB into 0, that is equal to 0. So this is the option to be ticked. This is the option that is the answer. Next question. Again a very simple question but a very illustrative one. The angle between two vectors is what? The first vector is A vector is equal to minus 2 I cap plus 3 j cap plus k cap, and the second vector is B vector is equal to I cap plus 2 j cap minus 4 k cap. So whenever we are asked to find out the angle, please note that we usually use the dot product because we have to deal with only scalars and hence we can omit components or we don't have to manage components. So A bar dot B bar is simply minus 2 into 1 is minus 2 plus 3 into 2 is 6 plus 1 into minus 4 is minus 4. So that gives you 0. So since A dot B is equal to 0, as seen in the previous problem, angle between A and B is 90 degree. Next question. We have to find out the angle between the vectors I plus j. So I vector is here, j vector is here, I plus j will be in this plane, and j plus k. The vector j happens to be here, k happens to be here, j plus k will be in the yz plane. The best way, as we have seen, to find out the angles is using the dot product. So A dot B is going to give us I plus j dotted with j plus k, j plus k. So this gives you I dot j plus j dot j plus I dot k plus j dot k. So this is equal to I dot j, which happens to be 0. This is 1. This is 0, and this is again 0. This happens to be 1. This is also equal to AB cos theta. And you can very well note the magnitude of the vector A is equal to magnitude of I plus j is equal to under root 1 square plus 1 square. Magnitude means the length of the resultant vector formed by the vector I and the vector j. So this is equal to root 2. Similarly, magnitude of vector B is also equal to root 2. So from this equation over here we get 1 is equal to root 2 cos theta. Therefore theta is equal to cos inverse of half, which is nothing but 60 degree. So this is our answer. C is the correct answer. Next question. A particle moves with the given velocity under the influence of the given force. Instantaneous power of the particle. Power is given as force dot velocity. So this is equal to 20 I hat plus 15 j hat minus 5 k hat dot velocity is, okay, the velocity has been given to be in meters per second and the force has been given in newtons. So our power output will be in watts or joules per second. We don't need any unit conversion, but it is generally speaking important to note whether we are going to require conversion of units in any problem or not. In this problem we can just go ahead, but because the units are both in the MKS or the SI system, 6 I hat minus 4 j hat plus 3 k hat. So taking the dot product, 26 are 120, 15 into minus 4 gives you minus 60, and minus 5 into 3 gives you minus 15. So the answer is 45 and the SI units is joule per second. Next question. A particle moves in the xy plane under the action of a force F such that the value of its linear momentum P at any time is Px is equal to 2 cos t, and the y component Py is equal to 2 sin t. A few lectures from now we will be studying about the Newton's law of motion, where we will know that the force is given as the derivative of the momentum. So this is going to be equal to dpx by dt I cap plus dpy by dt j cap. So that implies minus 2 sin t I cap plus 2 cos t j cap, whereas the momentum vector is equal to 2 cos t I cap plus 2 sin t j cap. I invite you to verify that f dot p turns out to be 0. Therefore angle between them, cos theta is equal to 0, and cos theta is equal to 0, I beg your pardon, and theta is equal to 90 degree. Yeah, theta is equal to 90 degree. That is option C. For two vectors A and B, A cross B happens to be 0, then the vectors have to be parallel or anti-parallel to each other, because A cross B involves sine theta, AB sine theta n hat. And sine theta can be 0 only when theta is 0 degree, 180 degree, 360 degree, and so on. So theta has to be either 0 or 180 degree. So the vectors are parallel to each other. Perpendicular, no. 60, no. 30, no. They have to be parallel to each other. The answer to this is B. The angle between the vectors A cross B and B cross A, we have seen that they are opposite to each other. A cross B and B cross A are opposite to each other. So the angle happens to be 180 degree, which is pi radian. Simple question. Okay, what is the angle between P plus Q and P cross Q? We have seen, guys, that P plus Q lies in the plane of PQ. That's natural using the parallelogram law. And P cross Q lies perpendicular to the plane of PQ. So the angle between them is 90 degree. Simple. 90 degrees pi by 2 radians. Okay. The unit vector perpendicular to the two vectors. Okay. So whenever you are asked a vector perpendicular to any two given vectors, the first thing that you should do is take cross product. So A cross B. This vector is our vector A and this is our vector B. So A cross B, let us use the determinant method. I, J, K. If you know how to use the determinant method, it is pretty straightforward and hassle free. So you need to know what determinants are and how they are solved essentially. So this is the I, J, K. This is 2, 2 minus 1, and this is 6 minus 3, 2. So this is equal to I hat 2 into 2 is 4 minus 3 into minus 1 is plus 3. So this is 4 minus 3 minus J hat 2 into 2 is 4 and 6. So this is 10. Take the help of a friend who understands how to use the determinant method to find out cross products in order to realize how I am doing this if you do not already understand it. So this is 2 into minus 3, which is minus 6, and this is minus 12. So the answer comes out to be I hat minus 10 J hat minus 18 K hat. So that looks like option C. The denominator has come simply because they have asked us to find out a unit vector, and for a unit vector we need to divide. So a unit vector in the direction of vector A is nothing but A bar divided by magnitude of A. So this simply is equal to the vector I hat minus 10 J hat minus 18 K hat divided by the magnitude of itself. That's 1 square plus 10 square plus 18 square. So that comes out to be, on simplification, I hat minus 10 J hat minus 18 K hat divided by 5 root 17. You can yourself try to simplify. It does come out to be this, and the answer has to be C. Two vectors A and B have equal magnitudes, then the vector A plus B is perpendicular to. A and B vectors have equal magnitudes. The vector A plus B has to be in the plane of A and B, right? So it has to be perpendicular to A cross B necessarily. We have seen this, guys, earlier. This is like a repeat question. Find the torque. Torque is defined as R cross F. Again, a simple question where we need to take the cross product. So this is nothing but I, J, K, 7, 3, 1 and minus 3, 1, 5. Okay, here I'll explain how to open the determinant. So firstly, you open it along a row. This is the row IJK. So firstly I write I hat and then I ignore this line and this line. So whatever is remaining, I write that down. So what is remaining is 3 into 5 minus 1 into 1. You have to cross multiply it. So that's 15 minus 1. Similarly, while writing J, I ignore this row and this row. So what is remaining is J 7 into 5, that is 35, minus 3 into 1, so that becomes plus 3. But you have to give alternate plus and minus signs here. So this is plus, this is minus, and this is plus. So here I'll have to write this with a minus sign. And lastly, plus k hat, because there is a plus sign over here. The plus and minus signs alternate when you are opening along a row or a column. Right now we are opening along the first row. So 7 into 1 minus 3 into minus 3. So that is 7 plus 9, which is actually equal to 16. So this gives me 14 I hat minus 38 j hat plus 16 k hat, which if you can see is option number A or option 1. Alright guys, let's move on to the next question. We are doing good. The value of A plus B cross A minus B. Very interesting. A plus B cross A minus B. So that is A cross A plus A cross minus B plus B cross A plus B cross minus B. A cross A happens to be 0. B cross minus B also happens to be 0. So A cross minus B is equal to minus of A cross B, and B cross A is also equal to minus of A cross B. This we have seen. So both these equal to minus 2 times A cross B. So minus 2 times A cross B is the answer, but none of the options match, so we have to convert it into 2 times B cross A, because that is one of the options. I'm simply using here the fact that A cross B is equal to minus of B cross A. Simple. The next question. Okay, this seems to be based upon Lami's theorem. So here what do we get? Tension. So this mass is in equilibrium. Please read the question carefully. One of the important mistakes that students make is they don't read the question carefully. Which of the statements is wrong has been asked. So naturally, since the mass is in equilibrium, tension, this is tension force, tension vector plus weight vector plus the pulling force P vector is 0. So this is a correct statement. The statement is correct, that we don't have to tick. Also, vector W and P are perpendicular to each other. So W square plus P square is going to be equal to some force which the tension is balancing. So in magnitude, the tension is the under root of W square and P square. So T square is going to be equal to W square plus P square. This is again correct. P is equal to W tan theta. P is equal to W tan theta. Why is that correct? Because T cos theta, which is the upward component of tension, is equal to W, and T sin theta is equal to P, the leftward component of tension. Therefore, tan theta is equal to P divided by W. Therefore, P is equal to W tan theta. So tension is equal to P plus W. This fourth option is the answer to be ticked, because we have been asked the wrong statement. Okay. The next question, the 30th question, and this is our last question for today. It is based upon Lami's theorem. We have seen Lami's theorem. This angle happens to be 90 plus 60 degree, which is 150 degree. So let me say that this tension is T. This tension has been given to be 30 Newton. The weight and the tension in the string OA in Newton are. So weight has been asked and tension T has been asked. So according to Lami's theorem, t divided by sine 90 is equal to 30 divided by sine 150 is equal to w divided by sine of, please figure out that the angle is 120. Now let us look at the sine graph. This is 90-degree right over here. So 150, which is closer to 180, is going to have a sine value of half, and 120, which is closer to 90, is going to have a sine value of root 3 by 2, because 120 mimics 60 degree. 60 and 120 degree are both equally away from 90 degree. Similarly, 30 degree and 150 degree are equally away from the zero values of sine graph. So basically what we get is t is equal to 30 divided by half is equal to w divided by root 3 by 2. Using the first part of the equation, t comes out to be 60, and using the second part of the equation, w comes out to be 30 root 3. That is option B, guys. And that concludes our introductory lecture to vectors. I hope you found some value in our teachings, and see you again in another physics video with another lesson soon. Goodbye.